Hello, I'm Manish. I work in the research team at Merit. Today I'll be talking about network reputation, some work we've been doing in this area. I've talked about it in the past as well, but this is more drill down, statistics heavy talk. So it's a very long talk. I'm only going to hit the highlights, but the slides are available online because some of the graphs do take some staring at to get information out. I'll try to point out the important things today though. The background, we're basing everything off of IPv4 address allocation distribution for the ARN region. This talk is focused specifically for this area. And then we commonly used block lists. And then the analysis we do really is for each country, ASN, BGP prefix. We do a breakdown for spam lists, malware, phishing, active malicious activity. We highlight some interesting points if there are any, and then we talk about more towards the end, a discussion on where this is going and what does it mean. The arrow.
Not responding. Arrow click. We're locked up. Take an interrupt.
Yeah, arrow key.
First, a quick background. The RBLs we're using, we divide them into three distinct categories. They're the spam lists, things like Spam House, CBL, BRBL, the Barracuda list, the Spam Cop, UC Protect. I'll only present a subset of this, but we have done the analysis and the results are somewhat similar, so it's okay to present a subset. The malware phishing lists that we use are the Serble, the Fish Tank, the HP hosts, and the active attack behavior lists we use are the Darknet Scanner list, which we maintain ourselves, the D-Shield, and the SSH brute force attacks. Now our goal here really is to look at relative distribution on these lists, or the occupancy on these lists of different country, ASN, and prefixes. Here's a quick summary of the address allocation distribution by country. It's extremely boring for the ARN region. I've done a version of this talk for LACNIC and for RIPE as well, and it's much more interesting because the distribution on address allocations per country are much more interesting. Basically, the ARN region is largely U.S. allocation. About 1.6 billion IPs have been allocated, and U.S. accounts for about 93% of all of them. 5% is Canada. Once again, here's a reminder of the three primary spam lists we're going to look at, and we're going to look at distributions across those. So, not a surprise, big allocations to the U.S. mean big allocations in the block lists. But what is interesting over here is the chart at the bottom, which is essentially comparing how across different regions the different percentages you see, and it's very interesting that the relative occupancy of the ARN region IPs on these different spamming lists is much lower, 6%, 1%, 1%, compared to RIPE region, for example, which is 51%, 30%, and LACNIC region comes in somewhere in the middle. What is one interesting thing that we do want to look at is what happens when you look at relative percentage or fraction of a network or fraction of a country that might be on a block list. And then you see actually something interesting starting to emerge. The top graph is just pure counts of different numbers of IP addresses per country that are on a blacklist, the Barracuda list. And on the bottom, you're looking at the relative distribution. That is a fraction of the total address that was allocated to a country that's on a list. And you can see it's starting to show a much more interesting trend. The same thing for the CBL data source, and it's roughly comparable. So, where are we getting at? Not all networks are created equal when it comes to entries on a spam list. In general, the ARN region has much smaller percentage of listings, and the only thing we can talk about is the US is such a large allocation that it sort of blurs out anything else. Moving on to the malware and the phishing list analysis, we do our methodology is the same, just take the list, resolve them to my IPs, and move on. And once again, comparing global distributions or or the percentages across different regions is an interesting comparison. For example, you'll see ARIN IPs over here form a much larger percentage of the total lists than, for example, say LACNIC or RIPE. So malware and phishing lists have a much higher occupancy of ARIN region IPs. This is the distribution by country for different lists that we categorize as active malicious activity. Once again, US is a big contributor, but if you look at the global regional comparisons, it's again an interesting comparison where the RIPE region IPs account for much higher percentages than either the LACNIC or the ARIN region IPs. So what you're starting to see is get a picture from a global perspective of how different IPs in different parts of the world are forming, coming together on these RBLs. Now we switch over and take a look, deep dive a little bit more, which is look at address distribution by ASN. So there are roughly 21,000 ASNs in the ARIN region. They account for about 140,000 prefixes in the BGP routing table. We focus on the largest 50 and then look at address block distributions across them. These are the top 10 converted to names, so roughly you know who these are. I apologize that numbers on this table are not correct. They haven't been updated, but it's just an indicator of what the top ASNs are. The numbers on this chart here are actually correct. So 721 would be about 80 plus million IPs and so on. This is a distribution just for a single spam list for the top 50 largest ASNs in the ARIN region. The top graph is showing the number of entries, and the bottom graph is showing you the relative fraction of that AS that is on the RBL. The green is showing you the total address space, and the red bar is showing you the number of entries on the RBL. The axis for the green line is actually on the right-hand side, and the axis for the red bars is on the left-hand side. Once again, some interesting highlights of the previous slide is basically Comcast has about 900,000 IPs on the BRBL. It's huge. But it's a very small fraction. If you look at something like BTN, they have almost 6% of their address space right here on the BRBL. 5 of the top 50 largest ASNs have more than 5% of their addresses on the BRBL. The absolute numbers become smaller for the other smaller lists, but the general trends still continue to hold. And it's important not just to look at the large numbers, just occupancy on these lists, but to look at the relative fractions of a network that are on these lists. This, for example, shows you a distribution for the top 1,000 ASNs to give you an idea of how many ASNs have what percentage. And almost 200 ASNs in the ARIN region have at least 10% of their IPs on the BRBL. Now, the BRBL is one of the largest spam lists. But even if you look at the CBL, about 10 ASNs have at least 1% of their IPs. If you look at distribution across malware and phishing domains, some trends, consistent trends do occur. AS 19318, for example, accounts for almost 23% of the entries. AS 6517, Reliance Globalcom, is about 5% of the serval entries and 12% of HP hosts. What's interesting here is that the trends are consistent. So even though these different data sources might be different methodologies, the results are somewhat in line. This is the same breakdown for malicious activity across different ASNs. 3491 shows up consistently across all of them, and so on. We repeat the same exercise on a per prefix basis. What you're seeing over here is a chart of activity on a spam list on a per prefix basis, and I'm only showing the top 50 prefixes. Once again, the green bars are showing total address space. That represents the prefix, and on the left axis is the number of entries on a RBL. The BGP ARIN region is about 138,000 prefixes, one large prefix, and the top 5 prefixes have 200,000 or more IPs on the BRBL. This is the same chart for the CBL. Once again, you see one outlier, and for the others, it's relatively smaller fractions. But what happens when you look at the fraction of the network that's on the RBL? So remember, over here we were looking at the top end of the prefixes, the large prefixes. If you look at the relative fraction of a network that might be on a RBL, you find that about 1,300 in-region prefixes have over 50% of the address space in the BRBL, and 2,500 prefixes have at least 25% of their IP address. And most of these prefixes are going to be /24s, /23s, and so on. This chart is comparing the relative amounts of IP addresses on the spam list as well. And once again, you can see it's a very clear tendency towards the smaller prefixes. So to summarize, what we're doing over here with network reputation is trying to construct a metric or a set of metrics that collectively can illustrate the reputation of your network. So hosts that are crossing your network that might engage in malicious activity, the activity doesn't go unnoticed. It's noticed globally. And in a lot of sense, we don't really understand why we might see regional variations that we do, what policies, topology, or connectivity might affect this. There are several things if you have a notion of another network's reputation that you can do. You might make decisions regarding whether to peer with somebody or not, depending on their network reputation. It's sort of like a credit worthiness check that you might wish to perform. You might wish to do BGP path selection based on a notion of neighborhoods, good or bad, around the internet. And in a sense, it's not just a matter of reporting or calling networks good or bad. It's about what can you do to manage this varied amount of information that you can have once you have this notion of different networks having different reputations, which might be an indicator of policies that they're adopting.
Very good. I know this is going to be online later. This is a deck that rewards close inspection over time. I think we have time for maybe one question if anybody wants to grab. Otherwise, you can meet Manish afterward. Oh, all right, we're good.